Okay, I think we are live and we can share the link with the participants. So, good morning, everyone, and welcome to another live session of this 2-week refresher course in computer science. This refresher course in computer science has been organized by the Department of Computer Science and Teaching Learning Center, Ramanujan College, under the Pandit Madan Mohan Malaviya National Mission on Teachers and Teaching Scheme of Ministry of Education. For today's session, we have one of a renowned scholar, Dr. Sandeep Tanwar, who is a senior member of IEEE and is working as a full professor at the Nirma University, India. He's also a visiting professor with Jen Vysotsky University, Poland, and the University of Pitești, Romania. Dr. Tanwar received his BTech in 2002 from Kurukshetra University, MTech in 2009 from Guru Gobind Singh Indraprasth University, Delhi, and his doctorate in 2016 with specialization in wireless sensor networks. Dr. Tanwar has authored 4 books and edited 20 books, more than 270 technical articles, including top-cited journals and conferences such as IEEE TNSC, IEEE TVT, IEEE TII, IEEE TGCN, amongst many others. He initiated the research field of blockchain technology, adoption in various verticals in 2017. His H index is 47. Dr. Tanwar's research interests include blockchain technology, wireless sensor networks, fog computing, smart grid, and the IoT. He is a member of the Technical Committee on Tactile Internet of IEEE Communication Society, and he has been awarded the Best Research Paper Award from IEEE IWCMC 2021, IEEE ICCA 2021, IEEE Globecom 2018, IEEE ICC 2019, and Springer ICRIC 2019. Dr. Tanwar has also won the Dr. K.W. Wong Annual Best Paper Prize for 2021, sponsored by Elsewhere. He has served many international conferences as a member of the organizing committee, such as the publication chair of FTNCT 2020, ICC 2020, and VMOB 2019, and a general chair for IC4S 2019, 2020, ICC SDF 2020, FTNCT 21. He's also serving as the editorial board of Elsewhere, IGCS Wiley, Cybersecurity and Application Elsewhere, Frontiers of Blockchain, and Spy Willy. He is also leading the ST Research Laboratory, where group members are working on the latest cutting-edge technologies. Today, Dr. Tanwar joins us as the resource person for speaking or sharing his knowledge with us, with the participants on the topic blockchain. We welcome you, sir, and we thank you for accepting a kind invitation. I request you to kindly take over the session.
Thank you very much. I hope that my screen is visible and my voice is also audible to all of you.
Yes, sir.
Yeah, let me open the pointer also so that things are much more understandable to the participant. So once again, thank you very much to the organizer for inviting me to share my view related to the blockchain technology. And in this particular presentation, we will discuss about blockchain technology, because I know that many of you are not aware about blockchain technology. So we will start from the scratch, that how it is going to helpful to the community at large. And if the time permit, we will see the possibilities that to cover one of the healthcare related applications. Okay. And before starting my technical discussion, let me just tell you that as rightly pointed out by the organizers also, in Nirma University, we are managing a lab of ST labs, where we are giving the flexibility to not only to the Nirma group students, but also if any of the student across the globe want to join our lab as a research intern, summer or winter research intern, 4 to 6 weeks or 6 months, then all those students are welcome to join our lab. And if you want to see the contributions specifically, because here in ST lab, we are working not only in the blockchain technology, but other cutting edge networking technologies like sensor network, like D2 device to device communication, smart grid communication, Internet of Things. So mainly we are working on simulation, analytical and experimental methodologies, and publishing the results in a top-cited transactions and top-cited SCI index journals. Okay, so I invite all the students, those are interested to or look for any internship, research internship opportunity, they can ping us so that we will see the possibility to include you as a research intern and give you a kind of a certificate also. Yeah. Now moving further, these are some of our research contributions with our UG, PG and PhD students only in the area of blockchain technology. So as you can see that most of our contributions are in the are published in IEEE transactions. These are very top tier transactions like IEEE TII, TNSC, TGCN, IoT. So now before starting my technical discussion or technical talk, it's a 1 hour talk. So let me share the disclaimer statement with all of you. In this presentation, I have put forward my own thoughts, my own experiences with my UG, PG and PhD students. I believe that when it comes to exploring a particular technology, then every individual is having their own viewpoint. So don't consider my discussion that I am going to share with all of you in the next 1 hour as a standard guideline, because every individual is having their own viewpoint. And I want to give the due credit to all the researchers, because while preparing these PPTs, I have come across some kind of good research articles and some content from the NPTEL and MOOC courses also. So the only purpose I have used their content is just only for the academic purpose. There is no commercialization involved in this entire process. Okay. So now this entire lecture, 1 hour lecture, I have divided into 3 parts. So in the first part, I am going to discuss about the blockchain technology. What is the actual meaning of blockchain technology? I am not directly jumping to the blockchain technology. I will tell you first what is the problem associated with the centralized approach and how these problems are to be overcome by adopting the blockchain technology. And in this particular part, we are going to discuss the different characteristics of blockchain technology, different tutorial, different terminologies through one very basic and simple tutorial regarding the blockchain technology implementation, because many of you are having this dilemma that this blockchain is a buzzing word, how it is different from the other technologies and how it is going to contribute to the not only to the companies but to the academic institutions at large also. So in the second part, if the time permit, then we will see how it is going to contribute to the healthcare. And this is very, very important for all of you, because as a country, citizen of India, it is our duty as a citizen. We want to see that what are the problems government has already identified in their adopting blockchain technology vision document by Ministry of Electronics and Information Technology in 2021. So I will try to focus the applications that the government has already identified, and after identification of these applications, government expecting from all of us, not only from the academia but also from the industry, that we jointly come up with, take some application and come up with some kind of solution. Now we are in the academic community, so sometime like we are having courses. So for the courses, we are having course outcomes, course objectives. So similarly, in line to that, I have prepared one slide for all of you to only see the learning objectives of this particular session. Why these learning objectives are so important? Because many of the students, they are sitting by because they want to learn, but some of them, they are sitting by having some kind of pressure or some kind of, so for them, I will tell you that it is going to be a good learning for all of you. And as a speaker, it is my duty that after attending this particular session, the first learning objective, all of you must be aware about that what are the different nut and bolts in the blockchain technology. Second, if you want to adopt the blockchain technology in the healthcare applications, then how you are going to adopt it. Third learning objective is what are the issues identified by the government of India and how these issues can be rectified up to certain extent after adopting the blockchain technology in the defined applications. And the last objective of this particular, or you can say the takeaway of this session is, if you are familiar with the blockchain, you are very curiosity about adopting the blockchain, then how can you frame out your own case study? So these all four are the learning objective of this particular talk. Now moving further, starting my technical discussion. So as I have already told you that I'm not going to discuss directly the blockchain technology. First, I will tell you that what are the problems with the centralized system, and then we are moving to the blockchain technology. So now let's say we will take a very basic and traditional way of document sharing, but I am considering the era of 90s. So in the era of 90s, so let's say, for example, if I want to share one document with one of my friend, there are plenty of ways available in that particular era. But let's say I consider a very basic way that let's say I have drafted one email and she is the sender and he is the recipient. Okay. So in that particular case, so let's say, for example, she want to share one Microsoft document with one of her friend. So she, in the era of 90s, I am talking, she drafted an email and make an attachment of that document. Okay. So now in that particular case, in the era of 90s, she is in a position to send the document, whatever she want to send to her friend, but both the user cannot simultaneously see the updation. Whatever changes he has made or he is going to make, the same is not going to reflected at his end in the era of 90s. So this is one of the problem associated with the traditional way of document sharing. This is not the way, or this is not the approach that we are looking for. Second, and the most prominent, most used technique nowadays is the Google Docs. So let's say as a teacher, I want to collect the information of 60 student information like the roll number, name, address, or something else. Then I just created a Google Doc and shared with the 60 student. And as a teacher, I can see that how many students have filled the data, how many students have not filled the data. So now in this particular case, one of the problem that we have encountered in our previous slide in the era of 90s, that both the user cannot simultaneously update the document. But if I am using the Google Doc for the purpose of document sharing, then this problem is rectified where both the user can simultaneously edit the document, or not only both the user, but multiple user can simultaneously update the document. So now in this particular case, there are a couple of problems associated with this way of document sharing, because Google Doc, as far as the storage capabilities are going to concern, I'm not talking about the accessing capabilities, but the storage capabilities are going to concern. This Google Doc is using the centralized approach. So now the next question comes, if I'm using the centralized approach in my network, then what is the harm? You know that in case of centralized approach, there is a single point of contact. So if there is a single point of contact, that means what? If there is a single point of contact, that means the dependency is more. So whatever be the reason, if I'm not getting any kind of response from the single point of contact, so my entire network goes down. Okay. So these are the problems associated with the centralized approach. And let me add one complexity to my previous question. So let's say, for example, if bandwidth remains to be an issue, forget about editing the document. Even though sometime in a realistic scenario, we are not in a position to open the document and do a kind of editing, whatever we want to perform. So this is not the solution that we are looking for. Solution for what? Solution for traditional document sharing or solution for document sharing. This is not the viable solution. Why? Because it uses the centralized approach as far as the data storage capabilities are going to concern. So these are the problems that we have discussed, and these problems are associated with the centralized system. The first one is single point of failure. Second one is if you are not having sufficient bandwidth, then you are not in a position to perform the editing in the document. And third one is the very, very dangerous problem that pertaining to the data. What happens if the server crashes and you are using the centralized approach? So sometimes the data recovery is a very tedious task. So these are the problems associated with the centralized systems or the centralized approach if we use while framing out our entire network. Now, still we are on the same problem. We have not get the answer to our problem that what is the best way of document sharing. But before coming to the answer of this question, let me just tell you about the three representations. So why these three representations are so important for you? Because in most of my presentation in the next 40 minutes, I am going to discuss more about the decentralized approach. But I need to compare as a speaker. It is my duty to aware you that how many type of representation of nodes are there, how many techniques are there. Those can be used in order to do any kind of network framing. So centralized approach we have already discussed. In this particular case, we are having a single point of contact. So if because of some network failure, because of some crash fault, I am not getting any kind of response from this central controller or the single point of contact, so my entire network performance goes down. So compared to the centralized approach, if I come to the decentralized medium of arranging the nodes, instead of having the single point of contact, I am having the multiple point of contact. So if you see the highlighted, the red highlighted circles I have highlighted, just these are the multiple point of contact. So now the next question comes, in a network, if I am having multiple point of contact, then what are the advantages that I am going to get? So let's say advantage number one, let's say because of some reason may be network failure or crash fault, I am not getting the connectivity or the response from this segment of the network, then no need to worry. I have other point of contact available through which I can get the data. So no need to worry. My network never goes down because these are the other point of contact available through which I can perform my intended network functionalities. Now, what is the third way of representing the node? The third way of representing the node is the distributed mechanism. Here, every individual node is connected to all the remaining nodes. So everyone individually perform collectively their own task. There is no central controller as we are having in case of centralized approach. So these are the three representation, although in my subsequent discussion, I am going to focus more on this decentralization. Okay. But as a speaker, it is my duty to tell you that how this decentralization is different from the centralized approach and the distributed approach. So if we consider the example, your blockchain is nothing but a kind of a multiple point of coordination. That is the reason why it is called the decentralized approach. And your intranet, internet, World Wide Web and email, all these are working on the principle of your distributed mechanism. So now still we are on the same question, that how we are going to get the answer of this question. So now still the question remains same. We have started our discussion. If I go back, we have started our discussion in the era of 90s. This is not the viable solution of document storage that we are looking for, where the problem is both the user cannot simultaneously update the document. Then we shifted to the Google Doc, but it's using the centralized approach for the data storage. This is not the way that we are looking for. Now, what is the solution? So let's say, for example, the solution is she want to send again the same problem. She want to send one Word document with one of her friend. So now if we make internet itself responsible in order to maintain the information consistency, then what happens? So you know it very well. Let me tell you first what is the meaning of information consistency. The meaning of information consistency here is, so whatever is the last updated transaction occurred in your network, the same is going to be reflected in the ledger maintained by each and every node. Okay. And why this information consistency is so important? Because of this information consistency, the network success is dependent on it. There is no question of monopoly. So now the next question comes, if we make internet only itself responsible in order to maintain the information consistency, then what happens? You know that internet is an open channel. So if internet is an open channel, that means it gives an invitation to the intruder, hey, come and perform some kind of malicious activities. Now the next question comes how we are going to proceed in this particular scenario. So the next question comes that what kind of access control policies we are having, whether we are using Kerberos, whether we are using password-based authentication or biometric-based authentication. So again, I can say this is not the practical solution that we are looking for. We cannot make internet only itself responsible because it's an open channel. So now what is the viable solution? So the viable solution is we are not going to replace the internet. We want to have the internet, but we are arranging these nodes in such a way that every node is connected to all the remaining nodes in a network. That means we need to arrange these nodes in a peer-to-peer manner. And you know that what is the meaning of this peer-to-peer network, where we are building a network where each and every individual node is connected to all the remaining nodes. Okay. So, but we need the internet. Why we need the internet? Because these nodes may want to communicate or may want to exchange certain data between each other. So that is the reason why we need the internet, in order to establish the communication between the different nodes in a multi-party scenario. So instead of maintaining the centralized database as we are maintaining in this previous example, here we are maintaining a decentralized database. What is the meaning of this decentralized distributed database? It is just like that. I am not maintaining the entire entry database to a centralized server. Instead of that, that replica is created and that ledger is maintained by each and every node. Okay, so that is the reason why this blockchain technology is called the distributed ledger technology. That is the reason. So now this is nothing but one of the example of blockchain, and this is the solution that we are looking for. Because if we are maintaining and managing a kind of a distributed and decentralized database, then this decentralized database itself maintaining the strong information consistency, because there is no question of monopoly at all. And this is the reason how it is different from the centralized approach. And this is the reason why nowadays companies and every individual and most of the sectors of industry 4.0, they are shifted, or they are in a position, or they are in a planning to shift their business from the centralized system to the decentralized system, because of the two parameters. The first one is security and second one is the privacy. Because blockchain is not only provide the security of your data, but also preserve the privacy of individuals. We will see in couple of few slides how it is going to store the going to provide the security to your data and going to preserve the privacy of the individuals. Now, this is the scientific definition of blockchain. Forget about what is mentioned in the PPT. I will tell you in a very simple way. So let's say in a class there are 60 students, and a teacher has identified 4 students, and they do not want to take part in the placement activity. They do not want to go for GRE, TOEFL and IELTS. When the teacher inquired, they say that the reason is we want to become entrepreneurs. So that is the reason why we have not taken part in the placement activity. And this is the reason why we have not taken part in the IELTS, GRE and TOEFL. Then teacher feel happy that then what is the problem? They say that technically we are very competent, and we know that if we 4 jointly start our own venture, then it is going to be a big success, going to be a win-win situation for all the 4. But the problem is we do not have trust on each other. Believe me, if the 4 person, they want to become entrepreneur and they want to start their own joint venture and they don't have trust on each other, then there is a big question mark on the success of that particular organization. All of you agree with me. So now coming back to what is mentioned in the PPT. So these 4 students, they need a kind of a platform which will help them in order to establish the trust. So the blockchain is going to help them in order to establish the trust without the question of any monopoly, and at the same time preserve the privacy of the individual. So we can say blockchain is a decentralized computation and information sharing platform which enables multiple authoritative domains. Multiple authoritative domains means the 4 friends who do not have trust on each other, but still they want to cooperate, they want to collaborate, they want to coordinate. For what purpose? In order to become entrepreneur, or in a rational decision making process. So this is a generic definition of blockchain technology, that how this blockchain technology is required and what this blockchain technology is doing. Now moving further, I will tell you in a simple way that how blockchain technology works. But prior to that, let me tell you that what is the reason. Let me tell you in a very simple way that in a normal financial institution, let's say I want to transfer 50,000 rupees from my account to my friend account, I have plenty of options: Google Pay, Paytm, or I can use NEFT, IMPS, Beam app I can use. Plenty of options are available. Let's say I have opted one of the easiest way, that one of the traditional way I can say. I have my account in Punjab National Bank, and my friend he's having account in State Bank of India. I have added his account, and after 2 hours, I am entitled to make the transaction. So I have added his account, and I have selected his account, and added the transaction ID and OTP. And once I have entered to complete the transaction, this request will go to the PNB server, and from the PNB server, it will go to the third party. And who is the third party? Payment gateways. So that means in a normal financial institution, if you want to commit any transaction, your request will go to the payment gateways like Paytm, PayU, or like Atom. All these are the payment gateway. Now the success of a particular transaction is dependent on what? Is dependent on the services provided by the payment gateways. Okay, so let's say I am having big doubt on the credibility of the payment gateway. Then what happens? So my entire money is in a trouble, not credited to the recipient, but debited from my account. Sometime it happens, but sometime automatically credited back. Sometime I need to initiate a query. So this is in a normal transaction, okay, normal banking system. Now come to how the same example I can execute with the help of blockchain. So now in a tutorial way, we will see that how blockchain works. So in order to just give you a kind of a tutorial approach, I have selected only 4 individuals in a particular network. So let's say in a particular network, we are having 4 individuals, X, Y, P, and Z. Okay, so 4 individuals are there in a particular network, and it's a peer-to-peer network. It's a blockchain network basically. So now, so let's say initially every individual is having $100 in their account. Just a hypothetical situation I have considered. So let's say the first transaction I want to initiate in this particular network, which contain 4 individuals, where every individual is having $100 in their account. So person X want to transfer $50 from her account to person Y. $50 he want to transfer. So it is a transaction between X and Y. So that means the X account is debited and Y account is credited. That means in a normal banking transaction, it has nothing to do with the account of P and Z. Okay. So, but in case of blockchain technology, what happened? In case of blockchain technology, this information that X has transferred $50 to Y is captured by the ledger maintained by each and every node. That means X has transferred $50 to Y. This information is captured by P, and this information is captured by Z. Although X, P, and Z is not the party of this transaction. Why? Because the reason is very simple. Later on, if the Y denies that, hey, I have not received any $50 from your side, how can you justify to X that, hey, you can see that I have transferred $50 to your account? How can you justify? In a normal financial institutions, we are having passbook. Okay, but here we are having the ledger. So this is the reason, another reason that why this technology is called the distributed ledger technology. Okay, so now let's say if I want to start another transaction. So Y want to transfer $30 to P. This is a transaction between Y to P, but this information that Y has transferred $30 to P is to be captured by the ledger maintained by each and every node. So that means Y to P 30, again, it is going to be captured by all the node. Why? Because later on, in case of any conflict, this ledger is going to be referred in order to take the final decision. So now let's say if we consider another transaction where person X want to transfer $80 to Z, C is not entitled to transfer. Why? Because he has already transferred $80. So the remaining balance is 50. So whatever balance is there in the account of individual, only that much amount the user need to submit to the to the recipient. Okay, so this is not a valid transaction because of insufficient fund. Because of insufficient fund, this is not a valid transaction. Okay, now this is a simple tutorial of blockchain technology to understand how the blockchain technology works. Now moving further, now I will show you that how this blockchain technology, what is the transaction life cycle of the blockchain technology. What is the meaning of this transaction life cycle? It means that from where the transaction will be started and up to what we can say that the transaction is completed. So let's say in a blockchain network, you are having 50 nodes. Okay, and out of these 50 nodes, any node want to start or any user want to initiate any new transaction. Okay, that means someone requests a particular transaction. This transaction may include any data storage, number one. Number two, this transaction may include any Bitcoin that he or she want to transfer. So whatever is the requested transaction is there, that requested transaction is broadcasted to the entire network. Why it is broadcasted to the entire network? Because in the entire network, we are having the legitimate user. Okay. So now, in order to check that this transaction belongs to whom, okay, so now in order to get the answer of this question, we have a validation process in the blockchain and verification process in the blockchain. We will discuss this validation and verification process after a couple of few slides, but I will tell you what is the consensus protocols or the nodes itself. They are competent to decide that which transaction there is going to be validated or which transaction is going to be declined. Okay, so once the transaction is validated, then this validated transaction is combined with the other transaction to create a new block of data for the ledger. So this the blue highlighted box, you can say that it is going to be a kind of a new block which contains this requested transaction is added into the blockchain, and this new block is then added into the existing blockchain. In this way, we can say that it is permanent and unalterable. We will see what is the meaning of this permanent and alterable. Sorry. So after this transaction is added into the existing blockchain, then this information is propagated to the user. Hey, whatever transaction you have requested, this transaction is completed. This is the way how transaction is initiated and how transaction is completed, and this information will reach back to the individual who have requested that particular transaction, and this is the different steps that your transaction will pass. So what is the internal structure of the blockchain? The internal structure of the blockchain is we are having a single blockchain. Inside the single blockchain, we are having multiple blocks, and inside the multiple block, we are having multiple transactions. So each transaction will have its own hash. Each block will have its own hash. What is the meaning of hashing here? Hashing concept is used here just to preserve the privacy of the individuals. Okay, so now moving further. So in the previous slide, I have given you a kind of a question that once the transactions are committed into the blockchain, no one have the right to modify that already committed transaction. How can I justify? Why? Because this blockchain is using the concept of Merkle tree root structure, where the Merkle tree root structure is used to organize all kind of transactions, and the root of the Merkle tree is used to do the verification. So in the previous slide, if you remember, we have noticed that who is going to verify the transactions. So this Merkle root is going to be used in order to do the verification of the transactions. Okay, so now let's say we know that this Merkle tree structure, your transactions are organized in a Merkle tree root structure. Now from the attacker perspective, if you want to explore, if you want to see how difficult it is to do tampering of data in the already committed transaction. So let's say, for example, consider a small fragment. 4 transactions T1, T2, T3, T4, they are already committed. That means, what is the meaning of committed? Committed means they are already inside the blockchain. As an attacker, I want to modify, let's say, consider a scenario. I want to modify transaction number T2. What it contains, the transaction number T2, maybe some data storage, maybe some kind of Bitcoin that you want to transfer from one end to another end. As an attacker, my intention is I want to modify the transaction number T2. So as an attacker, if I want to modify the transaction number T2, so I have already told you that for each transaction, we have to generate the hash using the SHA-256. So let's say, for example, H01 is the hash of transaction T2. If I want to change the transaction T2, that means the hash corresponding to the transaction T2, that is H01, is going to be changed. If H0 is going to be changed, that means your H0 hash of leaf node L1 is going to be changed. Why? Because while calculating the hash H0 of the leaf node L1, we have taken the transaction T2 hash H01 into consideration. If you see this particular mathematical equation, okay. Now, if this H0 is going to be changed because of H01, which is the hash of transaction T2, then your root hash is going to be changed. Why? Because in root hash, you have taken H0 into consideration while calculating the root hash. If H0 is going to be changed, that means it is single change in a particular network will change the entire or disturb the entire hierarchy of your network. That means it gives a kind of a intuition to the rest of the miners, hey, some malicious activities are going on in the network and please take some necessary action. This is the way how we can say that the tampering of data, once the transactions are committed, it is next to impossible, but 100% we cannot claim at any instant of time. Why? Because if you Google it, you will find a lot of instances where, or a lot of case studies where people have invested huge computing devices or high performance computing devices or GPUs, and they have computed the hash much more faster as compared to the actual mining process. So this is the reason, but practically it is very impossible. Okay, now moving further, how many types of nodes are there in the blockchain? So in the blockchain, there are three types of node. First one is the miner node. So when we have discussed about the life cycle of the blockchain, then I have told you that there is to do the authentication, authorization, and auditing. Who will do it? So it is the responsibility of the miner node to do authentication, to do authorization and auditing of all kind of transactions those are occurred in your network. Second category of blockchain node is the ledger node. What is the duty of the ledger node? Duty of the ledger node is to capture the history of all kind of transactions. It is just like that passbook concept we are having in case of the normal banking procedure. Third category node is the normal node. This normal node contains the full copy of the complete blockchain. So this is about the different types of blockchain nodes we are having, and these different types of blockchain nodes we are going to take into consideration while we are going to build up our own blockchain network for our own defined applications. Now, just to summarize what we have discussed, we have no need to write or no need to remember this definition line by line, but just you need to capture the screenshots while you understand, then only you understand the formal definition of blockchain. The first keyword is open. Why the keyword open is there in the definition? It is open to all. That means accessible to every user. There is no question of monopoly at all. Distributed or decentralized, that means in any round of mining, it is not captured by the single party. Everyone is at equal platform. There is no question of monopoly. Efficient, it is up to the application, up to the user, how many transactions you want to perform, how many blocks you want to add. That is the way we can say it's a scalable. But definitely scalability remains to be a very big problem in the blockchain network for some of the applications. Verifiability, why verifiability keyword is there? Because everyone can check the validity of the information, what is going on in the network, how many transactions are completed at any round of mining. Everyone is free to check. Permanent, we have already seen using the concept of Merkle tree. Once you have entered the transaction into the blockchain, no one have the right to modify or change it. So this is the formal scientific definition of blockchain according to me, where it is more focused on 1, 2, 3, 4, 5 keywords. So you just need to remember the meaning of these 5 keywords. If you know the meaning of these 5 keywords, then things are much more easy for you to understand the entire concept of blockchain. Now, the last part before we jump onto the implementation part, let me tell you the types of blockchain, because if you know what is blockchain, then the next question comes that how many categories of blockchain exist and how I'm going to select which category is more important for me, and how will I select out of the given types of blockchain, which type of blockchain is more suited to my defined application. There is no straightforward answer to your question. Why? Because it is dependent on the application for which you want to adopt the blockchain. So let's say, let me just tell you first the briefing about all these three, and then we will come to the same question again. Okay. So first type of blockchain is the public blockchain, or if you refer the literature, then you also realize that this public blockchain is also called it as a permissionless blockchain, where anyone can join the network at any instant of time. Second type of blockchain is the private blockchain or the permission blockchain, where no one can join the network at any instant of time. If you want to join the network, you have to perform certain specific tasks. Or very important, third type of blockchain is the federated or consortium blockchain. That means if a group of companies, they are coming together like IBM, Intel, they want to grab some kind of project from the government of India, then they have to come up with a kind of a joint venture. So now coming back to our previous question, before explaining these types of blockchain, how you are going to select which type is more appropriate for you. Let's say, for example, for my identified application, transaction speed is one of the parameter. What is the meaning of this transaction speed? That means TPS, transaction per second. How many transactions per unit time are settled, or how many transactions are you can accommodate or your network can accommodate. The more number of transactions you can accommodate in a less amount of time, that is more important parameter for me. So if this is the parameter for selecting the type of blockchain, then you can go with the private blockchain, because it's a lighter and faster as compared to the public blockchain, because in public blockchain it's an open blockchain. Okay, so a lot of other examples are also there, but if you talk about in terms of realistic examples of these public, private, and federated or consortium blockchain, then your Bitcoin and Ethereum, these are the example of public or permissionless blockchain. Your private or permission blockchain examples are Hyperledger or different variants of Hyperledger, Hyperledger Sawtooth, Hyperledger Indy. Then federated and consortium blockchain, Quorum and Corda, these are the example of federated or consortium blockchain. So let me just move on to the implementation part. I believe that my screen is visible to all of you. My browser is visible to all of you. Anyone just please reply.
Sir, it is visible.
Yeah, thank you very much. So now before moving on to the actual implementation, let me just tell you, let me share one resource with all of you. And let me just copy this resource to the organizers also, so that they will copy the same to the different platforms. See, in case of blockchain technology, it is not a kind of a old technology. It's a new technology, not fully matured. So the standard textbook is not available, okay, which will tell you exactly right from the scratch and having the implementation point of view. So since last 2 years, I worked on this particular project with the help of Springer, and we have already proofread the entire copy of this complete blockchain book, which contains 14 chapters. So maybe by June 2nd week, this book will be in the market. It's an authored book from my research group. So this book contains 14 chapters, and in every chapter you will find the different codes we have given to the benefit of the community, and the exact output, questions, detailed question, multiple choice questions, so many stuff we have given in this particular book. So whenever this book will release in the market, it is going to be the first detailed implementation book, start from the theory to practice related to the blockchain technology. Now moving to the implementation part, I believe that implementation is very important in the blockchain technology, from particularly in order to gain the technical depth in a particular in a particular topic of blockchain. So now in this particular implementation, we will see, if you want to build up your own blockchain, if you want to create your dummy blockchain, how can you create your dummy blockchain? So let's say, for example, fundamental, you know what is blockchain, how it works. Now the second aspect, it is not the end. If you know the fundamental aspect, fundamental part, then you have to go to the implementation and try to correlate what is there in grounded in the theory, and how this grounded, whatever is grounded in the theory, you are in a position to implement it. Okay, so in this particular implementation, maybe in the next 10 minutes, we will see that if you want to create your dummy blockchain, how can you create your dummy blockchain? This is not only the one implementation of blockchain. For implementing this blockchain, whatever I'm explaining to you, you need to have the Node.js installed, and you need to have your Visual Studio Code installed in your laptop or in your desktop. Okay. Now, in this particular implementation, we will explain it line by line. So here I have defined constant SHA-256 require crypto.js. So here I have already told you during my conversation that blockchain preserve the privacy of the individual. Here we are going to call the person by their name. So we need to provide the hash, or we need to give the hash to the different data or different individuals. So SHA-256 in this particular implementation we have used as a cryptographic primitive in order to generate the hash. So it is just like similar to you are writing the program in C language and SQRT function you want to use. But for using this SQRT function, you have to include math.h header file. It is similar to that. So crypto.js, I have included SHA-256. I have included in my implementation. Now, there is a time to create the block. So I have defined the block as a class. Now, once I define the block as a class, I need to define the instructor. I need to define the attributes of that particular class. Okay. So particular attributes like index, timestamp, data previous as. Index means what? Index means, let's say you are having 20 blocks. How you are going to differentiate these 20 blocks? That is the block ID. So index means block 1, block 2, block 3. Timestamp, it's a variable field. Timestamp associated with the block that you are going to create. It's again another attribute. Data, for what purpose you are creating this block, what kind of data you want to store inside the block. And the last field is the previous as. What is the meaning of this previous as? It is very important to understand the concept of previous as. Why? Because the structure of the blockchain is like that. The next block will store the hash of the previous block. Those who love the data structure, so there is a concept of linked list in the data structure. Here, this implementation or Nakamoto uses exactly the concept of linked list, where the next block will store the hash of the previous block. And why there is a requirement to do it? Because how these different blocks in the blockchain are interlinked with each other. So this is the mechanism how the different blocks in the blockchains are interlinked with each other. So once I have created the block as a class, now the next thing is I need to associate, or I need to calculate the the hash of the class that I have defined in my previous step using the SHA-256. So how many attributes I have taken? I have taken index, timestamp, data, and previous as. All these are encapsulated, and this function return SHA-256 will give me a single value, and that single value is the hash of the block that as a class I have created. And this is the code to create the block in a particular using the concept of class. Now the next thing, after creating a class as a block as a class, now the second thing is I need to create the blockchain again as a class. So the inside the blockchain, I need to create the first block manually. It is just like that, the first element of the array A of 0. Okay, so similarly, the first block of the blockchain you need to create manually, and that first block, whatever you have created, is called the genesis block. Okay, so it is the first variable of the array, and that will be is genesis block. You need to create it manually. Okay, so what kind of attribute you need to give to that particular block? The same attribute, whatever we had defined in the block as a class: index, timestamp, data, and previous as. So against the index, I have defined 0. This is the timestamp, and inside this genesis block, I want to store a message. This is a genesis block, and against the previous as, it's a 0. Why it is null? Because prior to that, we don't have any block. So this is the first block of the blockchain. That's the way against the previous as we are having 0. Now after that, it's a programming basically. Whatever application you are having, according to which you can decide how many blocks you want to create. So let's say if you want to create 1000 block, 100 blocks, so you can use the for loop also. You can ask from the user how many blocks you want to create. But here I have created only two blocks, block number 1, block number 2, followed by the Genesis block. Then once I have created these two blocks, I need to define the attribute of these blocks, same attribute, whatever as a class I have defined, index, timestamp, data, and previous as. Against the index, I need to give one, block number 1, timestamp, and my balance is the data containing 100 items. That as a data items, just a dummy value I want to store inside the block number 1, and similarly this same attribute or with a different value I need to store inside the block number 2. So once I have created the two blocks, now the next thing is there is a time to create a new blockchain. So earlier I have created a blockchain as a class. So now I have created my blockchain. Now it's the time to associate these blocks, whatever I have created, to my blockchain. So this is the code how you can create or how you can associate or how you can add the new blocks to the blockchain, whatever blocks you have created. Okay. So this is a very simple Node.js based implementation where we understand that how this blockchain concept is implemented. So now if you want to execute it, you want to go to the terminal, new terminal, open the new terminal, then node, you need to write the name of the file. Name of the file is blockchain.js. So once you click on enter, your entire program gets executed, and whatever value we have given, like if you see that for the Genesis block, we have given block 0. So index is block 0, timestamp, the same value will appear here. Now what I want to point here you have created 3 blocks, including the Genesis block. All these attributes are already there inside the blockchain. So this is the way how you can create the dummy block, entire or dummy blockchain you want to create, and how these 3 blocks, including the Genesis blocks, are interlinked with each other. You can see the hash field of the Genesis block. It is, I'm reading the first few alphabet, F29BE03. And if you read the previous hash field of the next block followed by the Genesis block, it is similar to the hash field of the Genesis block, F29BE03. That is, that process in the blockchain, we can call it as a hash validation process. That means whatever blockchain you have created, that blockchain is working on the exact principle of the blockchain or not. So this is a simple implementation of the blockchain where you, if you want to create your own dummy blockchain, Node.js based implementation. Now going back to our PPTs. So let me just move on to the another part, and then we will wind up. Okay. So so how will you decide that blockchain is needed actually? Because in the case of blockchain, the hype is more, but the reality is very less. What is the meaning? Meaning is, let's say I'm working in wireless sensor network, particularly in the cluster head optimization, but I am desperate to adopt the blockchain for the cluster head optimization as an application is wireless sensor network. So how can I visualize that how blockchain is going to contribute? There is no straightforward answer to this question. For getting the answer to these type of questions, you need to frame out a couple of questions. So I explored one of the literature written by Professor Osai, and it's a very good article where they have given a kind of a flowchart representation just to determine that whether a blockchain is the appropriate technical solution to solve the problem, yes or no. It's a very recent paper. So you need to frame out a couple of questions like, do you need to store the state? That means in your application, there is a requirement of memory, yes or no? If no, blockchain is not the right candidate for you. Don't go with the blockchain. Don't adopt the blockchain. Then if the answer to question number 1, I need the memory space for my application, I need to store the state, yes. Then the second question you need to frame out, are there multiple writers? That means multiple stakeholders are available. It's a multi-party scenario. If no, then blockchain is not the right candidate for you. If yes, you need to frame out another question. Can you always use trusted third party while performing your transactions? There is no doubt on the credibility of the third party. If yes, blockchain is not the right candidate for you. If no, then you need to frame out another question. Are all the nodes, all the users are known to each other? Are known to each other? That means if no, then permission blockchain is the right candidate for you. That means the public blockchain that we have discussed just a couple of minutes away. And then if all the nodes are not known to each other, if they are known to each other, then the next question you need to frame out, are all the nodes are trusted? That means there is no attacker available. Are you sure that in your defined network there is no attacker available? If yes, blockchain is not the right candidate for you. If no, you are not sure about the presence of the attacker, then is the public verifiability required? That means after committing every transaction, you need to verify, you need to validate. If yes, then you need to go for the public permission blockchain. Otherwise, you can go with the private permission blockchain. So this is a very good flow chart which will tell you the exact answer to your question, that whether the blockchain is the right candidate for your defined area in which you are willing to work or you have already working. Okay, so after that we will see that what are the initiative taken by the government of India. If you Google it, the initiative taken by the government of India for adopting the blockchain in the different government sectors, then Ministry of Information and Electronics and Information Technology, they have already released the vision document of adopting the blockchain in the government services in January or February 2021. There the government has already identified a couple of use cases for which they are taking the help of academia, not only the academia but industry, to come up with some kind of solution. I will throw some highlight on some of the use cases. Like first one is the transfer of land record. You know that country like India, a lot of forgery happen in case of transfer of land record. It's very tough sometimes to prove the ownership of the property. So government want to build up a kind of a decentralized land record transfer management system, and Telangana is leading in this particular use case. Then next is the digital certificate management, where no need to carry your PAN card, Aadhaar card, your 10th, 12th, BTech, MTech, PhD mark sheets, degrees. All these you need to give what? You need to give the employer only your hash code, and through that hash code, whatever functionality given to the employer can fetch the required detail. Okay, pharmaceutical supply chain is also one of the applications the government has identified. Like in the case of COVID-19 vaccine distribution, we have already noticed a couple of examples where central government has given these many doses to the different state governments, and how the central government can ensure that whether the state government is following the practices and procedure framed out by the central government efficiently or not. So that is the way they need a kind of a dashboard or the decentralized app through which everybody can be attached. Then e-notary services, couple of frauds also we have noticed in the paper-based e-notary system or also in the e-notary system. So government want to build up a blockchain-enabled e-sign document for the notary services. Farm insurance, we have already noticed couple of example in few states that where these insurance company, they are not giving the settlement amount to the farmers, or they are delaying, they are ignoring. So government want to build up a decentralized farm insurance system. Then identity management. In this particular case, IIT Kanpur is leading in the identity management. Power distribution, duty stamp, agriculture, e-voting, electronic healthcare is also one of the promising application, because in country like India, we are having personal healthcare record system. So government want to build up a electronic healthcare record system where all the detail related to the patient since the birth up to the death is managed at a single platform, and this is to be accessed by the doctor. No need to transfer, no need to carry any prescription diagnostic report. Only you need to carry your hash code, and once the hash code is entered by the doctor on the portal, doctor will see irrespective of the city, irrespective of the state, or sometimes irrespective of the country also, like in the case of European Union, Schengen countries, doctor can see what kind of allergies you are having, what kind of diagnose or what kind of treatment already taken, already applied. Okay, something like that. So government want to build up the EHR record management system, and couple of other applications also. So I advise all of you, please refer this particular document. This document will give you the clear-cut gist that how you are going to adopt in the different verticals. So some of the slide I am just skipping. and I will move on to the end of this session. So last word to say, if anything I have said seems useful to you, I am happy. If not, don't worry, just forget all about it. This was said by Honorable Dalai Lama, but in my context, I have changed it. If anything I have said seems useful to you, I am happy. If not, don't worry, soon all become necessity for all of us in the rapid change of technology where we cannot sit silently. So thank you very much to the organizer for inviting me to share my view related to the blockchain technology. And I hope that it is going to be a good learning for all of you, not only from the theoretical perspective, but from the implementation perspective also. Thank you very much, all of you. Over to you.
Thank you very much, sir. And it was really valuable session, and truly, the practical session was very informative. And the most of thing is what have you actually delivered, and that too in a very simplified way. That would be definitely beneficial to the participants. So before going to the a formal thank note, I request all the participants to throw some queries if you have certain regarding the session. So sir, just please wait. We are going to.
Yeah,
Okay.
no problem. Yeah.
So I request all the participants. I think your session was, quite self-explanatory, and you have delivered it well. I cannot see much of query over here on the YouTube because we are live on YouTube also, sir. And the same link is, running on our platform. That is our own LMS platform. So I think we can just wait for 1 or 2 minutes. Let's see if any query we have received. Otherwise, we can. I don't see any query. So I would say that this is the end of session. And in the end, I would like to pay my thanks to Professor Tanwa. The session was really real and practical knowledge over the blockchain, and most of it, as I said, you have delivered it in a very, very simplified manner, sir. And you have really made our technology so simple to understand for the participants. So thank you very much, sir, for finding time from your busy schedule, and we are really honored to have you as a resource person. So thank you very much, sir. And I would just request to end this session with the promise that we are going to invite you in the further session, and please just say a simple yes to us whenever we require.
My pleasure. Thank you very much to all of you. Thank you. Have a nice day. Yeah, thank you.
Thank you, sir.
Yeah,
Thank you.
Thank you.